All right, so at this point, you should have finished your evidence for each one of the claims that we included. You should also have submitted your forced gravity lab. At this point, we're going to move on to the last part with this lab, and that is being able to do some calculations, not only with forced gravity calculations, where you're actually calculating the weight of the object, but you can also do some calculations with calculating mass. So you should have already picked up the pink sheet from the substitute, and you need something to write with. So if you don't have those two things, go ahead and take care of it now. What I've done is I have just captured a screenshot of forced gravity versus mass. The mass is down here and the mass is in kilograms. And as we can see, as the mass goes up, forced gravity goes up. And specifically, I know that's hard to see, but the slope of the line is 9.8 newtons per kilogram. So therefore, what planet am I on? I am definitely on Earth because that is the gravitational field strength on Earth. Now, if we take a look at how to write an equation, we know it's a linear relationship, and we've done this lots of different times. So anything that's linear is going to use the generic y equals mx plus b format. And we know if we're looking at the equation for the relationship right above us, the two things that you fill in would be the m, which represent the slope of the line, and the b, which represents the y-intercept. So if you were in math class, you would write the above equation like this. You would fill in the slope, which is 9.8, bring down the x, and of course our y-intercept is 0, because if you have no mass, you'll have no forced gravity. Now, you don't necessarily have to write that piece. You can just leave it as y equals 9.8x. Now, the difference is when we write equations in physics, we don't want to call it y's and x's. We want to call it what it is. So I'm going to look at my generic relationship, and we're just going to put the physics language on there. So instead of y equals, we look at what is along the y-axis. And in this case, along the y-axis is forced gravity. So forced gravity equals. We know the slope of the line is 9.8. That's not anything different. And instead of using x, we say what is across the x-axis? And across the x-axis is mass. Now, the abbreviation for mass is an m. And then, of course, I don't have to worry about my b because that's going to be 0 anyway. Now, so if I wanted to take a generic equation for forced gravity and mass, we would just simply write it with no variables filled in. Instead, we would leave it at forced gravity equals the slope of the line, and we know the slope of the line represents gravitational field strength. The abbreviation for that is little g, strength, multiplied times the mass. Okay, and that is how you would do any calculations you want, is you would use this equation. So another way that we can do this is we can also refer to forced gravity as weight. So sometimes you'll see it a variety of different ways. You might see the equation written as forced gravity equals gravitational field strength times mass, like I have above. You might see it written as forced weight equals gravitational field strength times mass. Or, although I won't do this very often, it could be weight equals gravitational field strength times mass. So again, if I want to find the weight of the object on any planet, I just have to know two things. I got to know the gravitational field strength, and I have to know the mass. Now, one of the things you have to be super, super careful about is making sure you include your units all along the way. And so if I'm going to do a sample problem over to the side, and if I know that my gravitational field strength on Earth is 9.8 newtons per kilogram, and I know the mass of my object is 1 kilogram, I write it so you can see. If I know the mass of my object is 1 kilogram, my units are going to have to cancel. 9.8 newtons per kilogram multiplied times 1 kilogram. The kilogram on top cancels with kilograms on bottom, and that would leave me 9.8 newtons for a 1 kilogram object. Now, that fits the pattern. That's how I would show my work. Make sure that you show your work, your formula, your units, and you show your cancellation just like what I've done. Now, say I don't want to find forced gravity or weight. Instead, I want to find the mass of the object. I can do that pretty simply just by algebraically rearranging this. So I start with my generic starter equation. Gravitational field strength times mass equals force gravity. And if I want to isolate just the mass, then I simply have to send force gravity over to the other side. So whatever I do to one side of the problem, I got to do to the other side of the equation. So on this side, I would just simply divide both sides by gravitational field strength. Whatever I do to one side, I got to do to the other. So my gravitational field strength cancels on this side, and I'm left with mass over here by itself. So if I want to find my mass, I just have to know what my force gravity is, I have to know what my gravitational field strength is, and then I just rearrange that as well. Now, you are going to do the rest of the problems on this sheet. Please make sure that you include the units and the work all along the way. But before you do that, let's go ahead and flip to the formulas page. And let's go ahead and get these formulas added in so that you have them as quick reference so that we can use them frequently. So we know our formulas we've used for friction. Those are already there. So go below the friction ones. And let's go ahead and include our force gravity. So, force gravity is equal to gravitational field strength times mass. Another way I may write it would be force weight, same thing. If you want to put it in parentheses, that's fine. That tells me the same thing. Or you can say weight is equal to gravitational field strength times mass. Over here to the side, I'm just going to do a quick notation of what the symbols represent. Force gravity, of course, is F sub g. We know the unit for all forces is the same. The unit for forces is newtons. We know that gravitational field strength is that unique value specific to the planet. Okay, gravitational field strength. That comes from the slope of the force gravity mass lab, and the unit for that is a little different. It's newtons per kilogram. Newtons per kilogram. And lastly, we have M. M stands for mass, and the unit for mass is going to be in kilograms. Kilograms. So we can also add one more, and that would be the formula for mass. If you want to find mass, that would be force gravity divided by gravitational field strength. And I don't need to put the cheat sheet anymore because you already have it. Make sure that's written in your lab notebook. And go ahead and get started on the calculations. And then once you're finished with the calculations, you can glue them in.